Hi friends, in this tutorial series, we'll be implementing examples using Spring Boot 3 and Spring Security 6. In previous tutorial, we implemented basic authentication using Spring Boot 3. In this tutorial, we'll be implementing JSON Web Tokens using Spring Boot 3. We will also look at what are the drawbacks of using basic authentication and session management using cookies and why JSON Web Tokens are necessary. This I'll be taking reference of my website javanews.com. So go to Spring Boot 3. In Spring Boot 3, go to Spring Boot 3 Security. The example that we'll be implementing today is Spring Boot 3 JSON Web Token Hello World example. In previous tutorial, we implemented Spring Boot 3 Basic Authentication simple example. So in this example, we implemented basic authentication and also understood its internal working. You can go through this example here. Also in another previous tutorial, we had implemented Spring Boot 3 MySQL CRUD example using JPA. So we'll be modifying this example to implement JSON Web Token authentication. Also in the next tutorial, we'll be further modifying this example of Spring Boot 3 JWT to implement Swagger configuration. You can go through this tutorial here. Before we look at what is JSON Web Token and its other details and also why it is necessary, let us first have a look at the drawbacks of basic authentication. So in Spring Security, basic authentication is a very simple way to authenticate users based on the username and password. When the user tries to access a protected resource, they are prompted to enter the username and password. Only when these username and password they match with the ones that Spring Security has does the user gain access to this protected resource. Else they are denied access. And let us now consider a scenario where suppose Gmail server it makes use of basic authentication. So suppose if now a user he needs to access the inbox page from the Gmail server, then he will need to send a request to the Gmail server, and along with this request he will also need to send the username and password as we are making use of basic authentication. So the Gmail server will then authenticate the user based on this username and password, and if these credentials they are correct, then he will be responding back with the inbox page as the response to the user. Once the user he receives this inbox page as the response, now suppose he wants to access the sent mail page. So for this he will send a request to the URL /sent mail. Now as a user he has already authenticated himself in the previous request. So maybe in the sent mail request he will not send the credentials along with it. So in the sent mail it will not be having the username and password. Now as the Gmail server it is making use of basic authentication. So for each request sent, it needs this username and password along with it. And since the sent mail request it doesn't have the username and password, so at the Gmail end, the authentication it will fail. The user will not get the sent mail page as the response. So let us have a look at the drawbacks of basic authentication. So as seen previously, basic authentication it requires credentials to be sent along with each request. So this can cause man-in-the-middle attack. In case of man-in-the-middle attack, the request that is sent from the user to the Gmail server, it will be intercepted by an unauthorized individual. So this unauthorized individual will then gain access to the username and password that we are sending along with the request, and he can access sensitive information from the Gmail server. Suppose we need to give access to a particular user to access a protected resource for suppose only 1 day or n days. So this duration it can vary. Implementing such a use case is not possible with basic authentication. Another drawback is that basic authentication request it contains only credentials, that is the username and password. The request it cannot have additional security information like the user roles, expiration date or some other custom information. Next, let us have a look at the drawbacks of using session management using session IDs and cookies. So in case of session management, the user he will send the username and password to the server only once. So only in the first request, the user he will be sending the credentials to the server. The server receives this request and authenticates the user. So once the user is authenticated, the server it returns back a unique session ID to the user. These session IDs they usually contained within the cookies. So using cookies, the session ID it is shared between the user and the server. For all the future requests, the user now he does not need to pass the username and password with the request. He will just need to pass the session ID. So when the server it receives the request along with the session ID, checks whether there is any information corresponding to this particular session ID. If it is there, then yes, the request it is valid and it will allow the user to access the protected resource. Else it will not allow the user to access the protected resource. Next, let us again consider a scenario where the user he again wants to access some protected resource from Gmail server. So in this scenario, Gmail server will be making use of session IDs and cookies for session management. So here the user he will send the first request, and along with the first request he will be sending the username and password. The Gmail server when it receives this request, it will authenticate the user based on this username and password, and if the user is successfully authenticated, then the Gmail server it will create a unique session ID. So the session ID it is just a reference token. It itself doesn't contain any value. So corresponding to this session ID, the user he will be having some values like what is the role of the user, or suppose an expiration date, that is the time for which the user should be granted access to, and other values. So these values corresponding to the session ID, they are either stored in memory or in some database. Next, along with the response, the Gmail server, it also sends the session ID. So now the user, suppose he wants to access the sent mail page. So in this case, the user, he will send the request, and along with the request, it will be sending the session ID. So the Gmail server, it receives the session ID. It checks the information corresponding to this session ID that it has stored either in memory or in database. And if everything is right, then it returns back the response back to the user along with the session ID. So the user will be making use of this session ID for all future correspondence with the Gmail server. However, this approach of making use of session IDs and cookies for session management has a few drawbacks. So one of them is session ID, it is not self-contained. So as we have seen that it is just a reference token, it is just some random string. By itself, it doesn't have any data. So it is a reference token corresponding to which we get the values. So during each validation, the Gmail server, it needs to fetch the information corresponding to it. Another drawback of making use of session IDs is that they are not suitable for microservices architecture involving multiple APIs and servers. They are less scalable. So let us consider the above scenario where Gmail server, it makes use of session IDs for session management. So in this scenario, the user along with the request passes the username and password. So at the Gmail server end, the user, he is authenticated and a session ID is created by the Gmail server and it is passed to the user. Now suppose the user, he not only wants to access the Gmail protected resources, but also suppose the Google Drive. So he sends that request to the Google Drive along with the session ID, but this will not work. Why? Because the session ID, it is not self-contained as we have seen previously. It is just a reference token, and all the information corresponding to this reference token, it is stored by Gmail either in memory or in some database. So Google Drive itself cannot give access to the user based on the session ID. Now in order to improve the scenario, what can be done is that the session ID that is created, it is stored in some external cache or Redis server. So the Gmail server, when it authenticates the user, it will create a session ID and it will store all the information corresponding to it in an external database. So next time when the Google Drive, it receives a session ID, it can also validate the session ID by accessing this external cache. However, this approach, it has a drawback that this is a single point of failures. So if tomorrow this external cache, it goes down, it will affect multiple microservices. Next, we'll take a look at the working of the JSON Web Token and understand how it overcomes the drawbacks of basic authentication and session management using session IDs. Similar to working of the session management using session IDs that we saw previously, in case of JSON Web Token also, the user, he will need to pass the username and password once to the server. So in the first request, the user will be passing the credentials, that is username and password, to the server. So once the server, it receives the request along with the credentials, it authenticates the user, and if the authentication is successful, it returns back a JSON Web Token along with the response to the user. Now the user, he makes use of this JSON Web Token in all subsequent requests instead of the username and password. So let us again consider a scenario where the user, he wants to access some protected resource from the Gmail server, and the Gmail server in this scenario, it makes use of JSON Web Tokens. So here the user, he will send the first request to the Gmail server along with the credentials, that is username and password. The Gmail server will authenticate this user, and if the authentication is successful, then it will create a JSON Web Token using the secret key. Again, as the name specifies, this key, it should be a secret and it should be available only with the server who is going to authenticate the user. The Gmail server then sends the response back to the user, and along with the response, it also sends the JSON Web Token. Now suppose the user, he wants to access some other protected resource such as the send page from the Gmail server. Then now instead of sending the username and password along with the request, it will be sending the JSON Web Token. Gmail server then receives this request with the JSON Web Token. It validates the JSON Web Token with the secret key that it has, and then if the validation is successful, it sends back the protected resource, that is the sent mail page, back to the user along with the JSON Web Token. So the user will now make use of the JSON Web Token to access any protected resource from the Gmail server. Now suppose the user, he wants some protected resource from Google Drive instead of Gmail, then it can send a request to the Google Drive along with the JSON Web Token, and the Google Drive, if it has the same secret key that is present with the Gmail server, then even Google Drive, it can validate the JSON Web Token, and if the validation is successful, return back the protected resource back to the user along with the JSON Web Token. So if tomorrow the user, he wants to make use of some other Google services like Google Maps or Google Photos, he can make use of the same JSON Web Token, because each Google services, it will be having the secret key with it, and the user will then be authorized to access the protected resource. So making use of JSON Web Token allows for much more scalable architecture, and it is more suitable for microservices. Next, let us have a look at the advantages of JSON Web Token. So JSON Web Token, it is self-contained. It is a value token and not a reference token. So previously we had seen that session IDs, they are reference token. That is, they themselves do not contain any value, but the value corresponding to this session ID, they should be either stored in memory or in some database. But JSON Web Tokens, they are self-contained. That is, JSON Web Token themselves contain all the necessary information, and no corresponding information it needs to be stored in memory or in database. The next advantage of JSON Web Token is that it is digitally signed. So if any unauthorized user it intercepts the request and gets hold of the JSON Web Token and tries to modify it, then the server will know about it, that it has received a tampered JSON Web Token. This is possible because along with the JSON Web Token, a signature is attached. So in the next section, when we have a look at the structure of JSON Web Token, we'll take a look at how the signature, it helps identify if this JSON Web Token it has been tampered with. As we have already seen that JSON Web Token, they are more suitable for microservices architecture because they are more scalable. Other than this, JSON Web Token, it has other advantages like specifying other security information like expiration type, roles, and other security information in the token itself. Next, we'll have a look at the structure of JSON Web Token. So previously we have seen that JSON Web Token, they are self-contained, and also if someone tampers with JSON Web Token, the server will know about it. So let us see how this is possible. So a JSON Web Token, it consists of three parts: the header, payload, and signature, and all the three parts, they are separated by dots. So this is how an actual JSON Web Token it looks like. So this information inside the header, payload, and signature, it is in base64 encoded format. So let us have a look at these three parts in detail. So the first part is the header part. So in the header part, there are two properties. The first is the type, which will always be JSON Web Token, and the other is the algorithm. So this is a hashing algorithm with value RS512. So this hashing algorithm will be used when digitally signing this JSON Web Token. The next section of the JSON Web Token is the payload. So as we have seen previously that when the server, it receives the first request from the user, it contains the username and password. So the server, it authenticates this request based on the credentials that has been passed. And if the authentication is successful, then it creates a JSON Web Token. So when this authentication is successful, then the Gmail server, it creates this payload. So the payload, it contains the user and session information. So it contains information like what is the username, the role, the expiration date, that is the time for which this JSON Web Token is valid, and also other user related information. In subsequent requests, when the server will receive this JSON Web Token, then depending upon the content that is there in the payload, the server will decide whether to authorize the user to access the protected resource or not. So this payload information decides whether the user he gets access to a resource or not. The third section of the JSON Web Token is the signature section. So using the signature section, the server is able to validate if the JSON Web Token it is valid and it has not been tampered with. So a signature section, it is a combination of the header and the payload data. So we first create a signature string using the base encoded value of the header and the base encoded value of the payload. So we convert the header and the payload into base encoded format and concatenate it. Next, using the hashing algorithm RS512 that we have specified in the header, we create a digital signature using the concatenated string of the header and payload in base64 encoded format and the secret key which is available only with the server. The signature value is then stored in the third section of the JSON Web Token. Now let us consider the scenario where the user is sending a request to the server, and along with the server he is sending the JSON Web Token. Now suppose some unauthorized person, he intercepts this request and gets hold of the JSON Web Token. So he will try to change the payload of the JSON Web Token. So suppose he changes the username from user1 to user2. In this scenario, the unauthorized person, he does not have the secret key. So he will not be able to generate a new signature based on this payload and header information. So the signature, it cannot be modified by the unauthorized person as he does not have access to the secret key. So when the server, it will receive this tampered JSON Web Token using the header and the payload, and also with the secret key that the server has, it will again generate a signature, and it will check if the signature that is there in the JSON Web Token matches with the signature that it has just created using the header and the payload. Now in this scenario, as the payload it has been tampered with, so the signature will not match with the signature that we have already in the JSON Web Token. So the server will know that this JSON Web Token it has been tampered with, and it will not authorize the request to access the protected resource. Another important point about JSON Web Token is that the information that is there in the payload, it is visible to everyone. So if there is a man in the middle attack, he can still get access to the information that is there in the payload. So we should not pass any sensitive information like passwords in the payload. Also, if possible, we should encrypt the payload data to make it more secure. However, when making use of JSON Web Token, we can be sure that if anyone he has tampered with this payload data, then the server will come to know about it. This will be creating a JSON Web Token. So go to the link here. So for creating a JSON Web Token, we'll be making use of the online JWT generator. So here in the JSON Web Token payload, we specify what all information should be there in the payload of the JSON Web Token. So here we have the issuer, issue date, expiration, username, and role. So using this add claim button, we can add more data to the JWT payload. So here I'll be adding, suppose, the email ID of the user. Next, we'll be selecting the algorithm. So this algorithm, as we had seen previously, it is specified in the header section of the JSON Web Token. And using this algorithm, we'll be creating the digital signature. So suppose I select here HS512. Next is the key. So this is the secret key, and this should be present only with the server. So click on this create JWT. So this is a JSON Web Token that has been created for us. Next, we'll be inspecting the contents of this JSON Web Token that we have just created. So copy this JSON Web Token and go to the link here, online JSON Web Token decoder. So in this online JWT decoder, paste the JSON Web Token that we just created and click on this decode JWT button. So this is the information that is there in the JSON Web Token payload. So here we had specified the email ID as javanews@gmail.com. So it has been successfully added in the payload. So let us begin with the implementation part. We'll be modifying the code that we had previously implemented for Spring Boot 3 MySQL CRUD example. So for this example, we'll be implementing the JSON Web Token. Go to this example here. So in this tutorial, we had created a Spring Boot application to perform CRUD operations using MySQL database. So using Spring Boot 3, we had exposed some REST APIs using which the user he can perform the CRUD operations for the MySQL database. To better understand this tutorial, you can go through the YouTube video that I have given here. In this tutorial, we'll be modifying this example to implement security using JSON Web Token. So the user he will be able to access the APIs exposed by the controller only if the user he has valid tokens. The user does not pass valid JSON Web Token along with the request, then he will not be able to access the REST controller. So in order to implement JSON Web Token, we'll be modifying the source code that we had implemented for this tutorial. So for this, we'll be downloading the source code. So go below, click on this link here to download the source code, Spring Boot 3 MySQL CRUD example. The Spring Boot MySQL project that we just downloaded, it is a Maven project, so import it in Eclipse. Right click on pom.xml and run as Maven install. So this will build the project. So we'll download the dependencies that we have specified in the pom.xml. So here in the pom.xml, we have specified the dependencies, Spring Boot Starter Data JPA dependency and the Spring Boot Starter Web dependency. If we now go to source main resources, application or properties. So in the properties file here, we have specified the URL of the MySQL database that it will be connecting to. So we'll be creating a database named JavaNewsDB. Inside the JavaNewsDB, we'll be creating a table named employee for which we'll be performing CRUD operations. Also here I've started the MySQL database using the MySQL command line tool. Let us start the Spring Boot project. Run this as a Java application. So here the application it has started on port 8080. If we go to the controller class, here we have exposed various REST APIs. One of this is a post mapping with the URL /employee using which we'll be inserting records in the employee table of the MySQL database. If we go to the MySQL database, so if we go to the JavaNewsDB, and here if we do a select star from employees table, here we already have some records inserted using the post mapping in this table. Also in the controller class, we have defined a get mapping with the URL /employees, which retrieves all the records that are there in the MySQL database. So let us make use of this get mapping. So go to Postman, and here we have localhost 8080 /employees. So this will retrieve all the records that are there in the MySQL table. Click on send. So here we have retrieved the records that are there in this MySQL table. So there are 3 records which are getting displayed here. Next, we'll be modifying this example such that the user he will be able to retrieve these records using the /employees URL only if a valid JSON Web Token is provided along with this request. So let us begin with the implementation part. So in the pom.xml, we'll be adding the Spring Boot Starter Security dependency and 3 JSON Web Token dependencies. Copy this, go to the pom.xml and add it here. Build this project to run as Maven build, Maven install. So this will download the dependencies that we just added. For implementation of JSON Web Token, we'll be dividing the workflow in 2 parts. The first part is to generate the JSON Web Token and the other part is to validate the JSON Web Token and get access to a protected resource. So first we'll be implementing the workflow for generating a JSON Web Token. Generating a JSON Web Token, we'll be exposing a post REST call with the URL /authenticate. So these credentials, they will be validated, and if successful, then a JSON Web Token will be generated and returned back. Also in the Spring Security configuration, we'll be whitelisting the URL /authenticate so that Spring Security doesn't block this URL /authenticate and it allows it to pass through. This is the workflow that we'll be having for generating the JSON Web Token. In this diagram, the class names with blue color, they are Spring Security classes, and the classes with black color, they are the classes that we'll be creating. So let us have a look at the flow. So the user, he will make a post call to the URL localhost /authenticate with the username and password in the body. So this request, it will be intercepted by the filter chain. From the filter chain, various Spring Security filters get called. So one of these filters will be the JWT request filter, which we'll be creating. And this JWT request filter, it extends the once per request filter. So as the name suggests, once per request filter means that this filter, it will be called only once. The JWT request filter, it will check if the incoming request that it has intercepted, it has any JSON Web Token in the headers or not. If it does not have any JSON Web Token in the headers, then this JWT request filter, it does nothing. So in our case, as the incoming request, it has no JSON Web Token in the headers, so the JWT request filter, it will do nothing. The filter chain will then call the other security filters in the filter chain. One of the last filters to get called in the filter chain is the authorization filter. The authorization filter, it checks whether the previous security filters that got called from the filter chain, they have authenticated the incoming request or not. So if they have authenticated the incoming request, then it will allow the request to pass through, else it will not allow it. Also, the authorization filter using the request matcher delegating authorization manager, it checks whether the incoming request, it has been whitelisted in the Spring Security configuration. If so, then it allows the request to pass through. So in our case, this scenario, it will be true as the /authenticate URL is whitelisted in the Spring Security configuration. So the authorization filter, it allows this request to pass through, and this request then finally reaches the JWT controller, where we'll be exposing a post endpoints with the URL /authenticate. The JWT controller will be validating the username and password that are passed in the post request of the incoming request. So the JWT controller, it makes use of the DAO authentication provider for authentication. Also, the DAO authentication provider, it makes use of the user detail service IMPL class to load the user details, that is the username and password, against which the username and password from the incoming request, they will be compared, and if equals, only then the authentication will be successful. Once the authentication is successful, the JWT controller, it will make use of the generate token method of the JWT token util to generate a valid JSON Web Token and return it back to the user. So let us create the classes that we have defined in this workflow. The classes that we will be creating are the JWT request filter, the JWT controller user detail service IMPL, JWT token util, and the Spring Security configuration class. So let us first create the JWT request filter. The JWT request filter will be making use of the component annotation. Also, this JWT request filter class, it extends the once per request filter. So the once per request filter, it provides the doFilter internal method, which is overridden by the JWT request filter. In this method, we'll be checking if the incoming request, it has a JSON Web Token in the headers or not. So here for the incoming request, we get the header with the name authorization. Also, we check whether this authorization header, it begins with a bearer string. If so, then it contains a JSON Web Token, else it does not contain. So in our case, this will be false and we'll just be logging a warning statement here. Finally, the request and response, they are passed to the next filter in the filter chain. Let us create this JWT request filter. Go to Eclipse and create a new class. The package will be conf.javanews.boardmysql CRUD.config. Copy the contents of this class. Next, we'll be creating the JWT user detail service class, for which we make use of the service annotation. And also this class, it implements the user detail service interface. It overrides the load user by username method, which takes the parameter username. So corresponding to this username, it will return back the user details. So here we'll be returning back a new user with the username Java News and the password as password. So we have seen in the previous Spring Security basic authentication tutorial that Spring Security, it makes use of bcrypt encoding to store the credential password. So here we are storing the password in bcrypt format. During the authentication process, the DAO authentication provider, it makes use of the JWT user detail service class to load the user details. These user details are then compared with the credentials that are provided in the incoming request, and if they match, then the authentication is successful. So let us create the JWT user detail service class. Go to Eclipse. In the service package, we'll be creating this class. Copy the contents of this class. Next, in the application.properties configuration file, we'll be specifying the JWT secret. So this JWT secret is present only with the JWT server and it should not be shared with anyone. The JWT server, it makes use of this secret key to verify the signature and ensure that the token, it has not been tampered with and can be trusted. So we have already seen previously how we make use of this JWT secret key for signing the JWT token. Copy this JWT secret key, go to the Eclipse project, source main resources application.properties, and paste it here. Next, we'll be creating the JWT token util class. For this class, we make use of the component annotation. In this class, we'll be creating a JSON Web Token. We'll be making use of the generate token method, which takes user details as the parameter. This generate token in turn calls another overloaded generate token method, to which we also pass an empty hash map. So this empty hash map, it returns the extra claim. So currently we do not have any other extra claims we want to add to the JSON Web Token. So this will be empty, and we again pass the user details. The overloaded generate token method in turn makes use of the build token method, to which we pass the extra claims, which is the empty hash map, the user details, and also we pass in milliseconds the expiration date we want for this JSON Web Token. So here for the build token method, we have the extra claims, user details, and the expiration value in milliseconds. We create the actual JSON Web Token using the JWT's builder method. So we set the claims, which will be empty. Next, we set the subject. So this will be user details.username, issue date, which will be the current date. We set the expiration date, which will be the current date plus the expiration value in milliseconds. So we have specified here the expiration value as 1 million milliseconds, which is approximately 15 minutes or something. And finally, this created JSON Web Token, we sign it using this JWT secret key that we have specified in the application.properties file and the HS256 algorithm. Let us create this JWT token util class. Go to Eclipse and here at config, create a new class. Copy the contents of this class. Next, we'll be creating an entity class named JWT request. So we'll be making use of this class for holding the incoming user request details like the username and password. So it will be having two fields, the username and password and the getters and setters. So let us create this class. Go to entity package and create a new class here. Copy the contents of this class. Next, we'll be creating another entity class named JWT response. This class it will be having a single field JWT token and it will be used to return back the response, that is the JSON Web Token, back to the user on successful authentication. Let us create the JWT response class. Here in Eclipse, create a new class, JWT response. The contents of this class. Next, we'll be creating the JWT authentication controller in which we'll be exposing the REST post endpoint with the URL/authenticate. Also in this class, we'll be auto-wiring the authentication manager. So later in the Spring Security configuration, we'll be creating the authentication manager bean. So by default, this will be the DAO authentication manager. Next, we'll be auto-wiring the JWT token util class that we just created. Also, we'll be auto-wiring the user detail service class that we created. So in order to generate the JSON Web Token, the user will be making a post call to the URL/authenticate. And also in this post body, he will be passing the username and password, which we'll be having in the JWT request object. So in this create authentication token method, once we get the JWT request, we call the authenticate method to which we pass the username and password that we get in the incoming request. In the authenticate method, using the authentication manager, we call the DAO authentication provider and call the authenticate method of the DAO authentication provider to which we pass the username password authentication token which is created using the username and password which is passed in the incoming request. So here the authentication takes place, that is the username and password that is provided by the user. It is compared with the credentials that we have in the user detail service. So here in the user detail service, we have the username as Java news and the password also as password, which is in decrypt encoded format. If they both match, then the authentication it will be successful. So once the authentication is successful, then in the create authentication token method, we call the generate token method of the JWT token util to which we pass the user details. So this generate token method, it generates a JSON Web Token, which is then returned back to the user. So let us create the JWT authentication controller. Go to Eclipse. Here in the controller, create a new class. Copy the contents of this class. Let us create this JWT token util class. Go to Eclipse and here at config, create a new class. Copy the contents of this class. For generating the JSON Web Token, finally we'll be creating the Spring Security configuration class. So in this class, we'll be creating beans of type authentication manager and password encoder. The password encoder, it will be of type decrypt password encoder. Also here in the filter chain method, we'll be configuring HTTP security. So here for HTTP security, we are whitelisting the URL/authenticate, which we'll be making use of to generate JSON Web Token. Also for HTTP security, we'll be adding the filters JWT request filter that we just created, and also the username password authentication filter. So let us create this web security configuration. Go to Eclipse. So we'll be creating this class in the config package. Copy the contents of this class. So we are done with all the coding changes required for generating a JSON Web Token. Next we'll be testing these changes. So for this, I'll be adding some debug points. So I'll be adding the debug point in each of these classes that we had seen previously when trying to understand the JWT workflow. So these classes are the filter chain, JWT request filter, authorization filter, JWT controller, the provider, user detail service ISP, and the JWT token util. So go to Eclipse and here first go to the filter chain proxy. In filter chain proxy, go below here to do filter method. So add a debug point here. Next, go to the JWT request filter class, add a debug point here. Next, go to the authorization filter. So here add a debug point. Go to the JWT controller class. So here I'll be adding the debug point. I'll be adding the debug points also in the JWT token util. We'll be calling the generate token method. And finally, we'll be adding the debug point in the JWT user detail service class. So let us start the Spring Boot application in debug mode. But before we do this, As this so let us start the Spring Boot project in debug mode. But before we do this, as this project, it performs MySQL CRUD operations. So we'll first need to start the MySQL database. So for this, we'll be starting the MySQL command line client. So now start the Spring Boot application, debug as Java application. So here the application, it has started successfully on port 8080. Next, using Postman, we'll be making a post call to the URL /authenticate, and in the body we'll be passing the username and password, that is Java in use and password. So click on send. If you now go to Eclipse, here in the filter chain proxy, we have got the incoming request. So in the filter chain proxy, various security filters, they get called. So the first filter that will get called is the disable encode URL filter. We are not interested in this. Webasync manage integration filter, no. Security context filter, header writer filter, cost filter, logout filter. So the next filter that will be called is the JWT request filter. So we have already added a debug point there. So here in the header, currently we are passing nothing. So nothing will happen here, just the log statement, it will get printed in the console. So here it has got printed and it will move forward. So we'll be back in the filter proxy chain. Now let us move forward. Next filter that we are interested is the authorization filter. So in the authorization filter, we have already added a debug point. So in the authorization filter, we have the authorization manager, that is the request matcher delegating authorization manager, which checks whether this URL, that is /authenticate, it has been whitelisted by Spring Security or not. So as we have already whitelisted this in the Spring Security configuration, therefore this authorization, it will pass. So here the authorization decision, it will be true and will move forward. So now this request, it will directly hit the JWT controller. So here we are inside the JWT authentication controller. So in the JWT authentication controller, in the JWT request object, we get the username and password that has been passed by the user. We call the authenticate method next. I'll just add a debug point here. So the authentication manager, it will call the DAO authentication provider. So press Ctrl+Shift+D, go to DAO authentication provider. Here we have the abstract user details authentication provider, go here. And here we'll be having the authentication method. So this authenticate method, it will get called. So go back to the JWT authentication controller. I'll just add more debug point here. So here we are in the authenticate method of the DAO authentication provider. So what this authenticate method will do is that the incoming credentials, they are compared with the credentials that we have in the user detail service. So here if you move forward, here it will retrieve the user details from the user detail service that we have just defined. Let me just add a debug. So here we are inside the user detail service, JWT user detail service. It will return back these details. So once we have these details, then these details, they are compared with the incoming request. And if everything is fine, then this method, it will return authentication as successful. So I'll move forward. So here, as we did not get any exception here, it means that the authentication, it was successful. Next, again, we load the user details using the user detail service. So using the user details that we just retrieved, we'll be calling the generate token method of the JWT token util. So in the generate token, we'll again call the overloaded generate token method here. And finally, we'll be calling the build token, which will actually generate a JSON Web Token. So here we get the secret here. So this will generate the JSON Web Token for us and return it back. So here the JSON Web Token, it has been created. Now this will be returned back to the user. We'll go back to Postman. Here in the body, we are getting back the JSON Web Token. So a generate JSON Web Token workflow is working good. So now that we are done with generating the JSON Web Token, let us look at how we can make use of this generated So now that we are done with generating the JSON Web Token, let us look at how we can make use of this generated token. So now that we are done with generating the JSON Web Token, let us have a look at how we can make use of this generated JSON Web Token in a Spring Boot application for validating the input request. Previously, we have exposed a post REST endpoint with the URL /authenticate for generating a JSON Web Token. Other than this, there are other REST endpoints that we have exposed in the employee controller. And one of them is the get REST endpoint with the URL /employees. This fetches the list of employees from the MySQL database. Let us see what happens now if we try to access the /employees endpoint. So go to Postman. Here we have localhost 8080/employees. Click on send. So here previously we had added some debug points in the filter chain proxy and other classes. So the next filter that will get called is the disable encode URL filter. Move forward. WebAssembly manage integration filter, security context holder filter, header writer filter, course filter, logout filter. Then here we have the JWT request filter. We have added a debug point here. Let us see what happens. So here again, since in the header we have not added the JSON Web Token, so nothing will happen, just a log statement will be there. Let us move forward. Then we'll be interested in the authorization filter. So here we have the authorization filter that will be called next. So as we have previously discussed, this authorization filter, this is the filter that checks whether all the previous filters they have authenticated the incoming request or not. If yes, then the request is allowed to move forward, else it is not allowed to move forward. So let us go to the authorization filter. So currently for this request, no previous security filter has authorized it. So if we move forward, also the authorization filter using the authorization manager, that is the request matcher delegating authorization manager, checks if this incoming request, it has been whitelisted in the security configuration or not. Since we have not whitelisted this employee's URL in the security configuration, so this will return false. So here the decision, we get it as false, that is this request, it should not go forward. So it throws an access denied exception. If we now go to Postman, here we get 403 forbidden. So we need to make use of the JSON Web Token in order to access this endpoint/employees. Next, if you go to the online JWT decoder tool, so in this tool, we'll need to enter the JSON Web Token. So previously we have generated a JSON Web Token, just copy this. Click on decode. So here we can see that our JSON Web Token, we have three claims. One is the subject, that is sub, which is Java in use, then issued at and expiry date. So here we can see that as a subject, we are passing the username. So let us finally look at how we'll be validating the JSON Web Token in a Spring Boot application. So the user, he will be making a call to the get endpoint/employees, and along with this request, it will also be passing the JSON Web Token in the headers. So this request, it will be intercepted by the filter chain, and one of the filters that will be called is the JWT request filter. Currently in the JWT request filter, if the incoming request, it has a JSON Web Token, then we are doing nothing. So now we'll be adding some more logic. If the JSON Web Token, it exists in the headers. So what we'll be doing is from the JSON Web Token, we'll be extracting the username. So we have already seen that the JSON Web Token, it has the username as a subject. So we'll be extracting this, and based on this username, we'll be fetching the user details using the user detail service INPL class. Once we get the user details, we'll be calling the validate token method of the JWT token util that we'll be implementing. To this validate token, we'll be passing the user details as well as the JSON Web Token. So in this validate token, we'll be validating if the incoming JSON Web Token, it is valid or not. And if it is valid, then it will return true to the JWT request filter. So now that we know the JSON Web Token is valid, we'll be configuring Spring Security so that this incoming request, it passes authentication in the Spring Security filters and is allowed to hit the employee's controller. So let us begin with the implementation part for this workflow. So we'll first be modifying the JWT token util class. So we'll be adding methods to extract the username from the JSON Web Token and also validating the JSON Web Token. Next, we'll be modifying the JWT request filter to add this logic of validating the JSON Web Token. In the JWT token util class, currently we have only the generate token methods. So we'll be adding some more methods in this class, and one of them is the get username method, to which we pass the JSON Web Token. And from this JSON Web Token, the username is extracted. So get username, it makes a call to the get claim method. So in the get claim, we know that the username, it is stored as a subject. So here we pass a get subject, and this retrieves the username from the JSON Web Token. Also we'll be adding a method validate token. So to this method, we pass the token as well as the user details. So the details in the JSON Web Token and the details in the user details, they are compared, and if they are equal, then it returns true. So here what we are doing is, first from the JSON Web Token, we get the username, and we also get the username from the user details, and if this matches, and also if the JSON Web Token, it has not expired. So here we have the isToken expired method. So this method checks if the JSON Web Token, it is valid and it has not expired. So if both these are true, then the validate token method, it returns back true. So currently in the JSON Web Token, we have only the subject claim which has the username, which we are comparing from the user details object. But we can also have other claims in the JSON Web Token, like maybe roles, which will also need to be compared with the user details roles, and only if they are equal, then the validate token will return true. But currently we are just comparing the username. Let us make these changes to the JWT token util class. Here go to the JWT token util class, and we'll be adding the methods here. Next, we'll be modifying the JWT request filter class. So currently in the JWT request filter class, we check whether for the incoming request in the headers a JWT request is present or not. If it is present, then we have this if loop here. Currently in this if loop, we are doing nothing. So next we'll be adding some more logic here to extract the JSON Web Token and validate it. So now when we'll be making a call to the get endpoint / employees, in the header we'll be adding the JSON Web Token. So here we do this by going to authorization tab. In authorization, we add the bearer token, and here in the token we add the JSON Web Token. So here in the post call we have a JSON Web Token that we just generated. Copy this, and here we'll be adding a JSON Web Token. So now when we make a call to the endpoint / employees with this JSON Web Token as a bearer token, then in the header, this bearer token, it is set as an authorization header, and it will be in the format bearer space and then the actual JSON Web Token. So in the JWT request filter, from the incoming request, we get the authorization header. So this will give us this entire string, bearer space and the JSON Web Token. Now we need to extract the JSON Web Token from this entire string. So what we'll be doing is, we'll be getting a substring after 7 characters. So the entire substring after 7 characters, it will be the JSON Web Token. So this is what we are doing here. JSON Web Token is equal to request token header that we just got the authorization header, substring 7, so that we get the JSON Web Token. So once we get the JSON Web Token, then using the get username from token method of the JWT token util, we extract the username from this JWT token. So if this username, it is not null, and also if this incoming request, it has not been previously authenticated, then we validate this token. So here we call the validate token method of the JWT token util class, to which we pass the JWT token and also the user details that we have loaded, making use of the username that we extracted from the JWT token. And if this validation, it is successful, then we create a username password authentication token, and this token we add it in the security context holder, so that the authorization filter, which will be called later, will know that this request, it has been authorized and it can move forward. Let us make these code changes. So we need to auto-wire the JWT user detail service and the JWT token util in this JWT request filter class. So here I'll be auto-wiring it. Next we'll be adding the logic here. We are done with the code changes. Let us now test these changes. So I'll again be starting the Spring Boot application debug mode. So now I have disabled the endpoint here. Let us quickly generate a JSON Web Token, because the previous one, it might have expired. Here we have got the latest one. In authorization, I'll be adding this. Also, I'll be enabling the debug points again and click on send. So here we are in the filter chain proxy. We are interested in the JWT request filter. So here the JWT request filter, it will get called. Also we'll be adding there some debug points in the JWT token util class. So here we'll be adding the debug point and get username, and also in validate token. So let us move forward. So here we are in the JWT request filter class. So we get the JSON Web Token in the headers. So if you look at the string here, JWT request token header, it has bearer space and then the JSON Web Token. So we extract the JSON Web Token. Next we make a call to the JWT token util get username from token. Also add debug point here. Okay. Let us move forward. Waiting on this. Okay, actually I did not add the correct debug point here. So here we have got the username from the JWT token util generate user from username, which is Java use. And also since the security context filter get context get authentication, it will be null as this request, it has not still been authenticated. So next, from the user detail service, we load the user details based on this username. So here we get the user details, that is username is Java in use and the password, which is in bcrypt encoded format. And currently there are no roles in this user details. So this is returned back. Next we call the validate token. To this we pass the JSON Web Token and the user details. So here we are in the validate token method. So here we check if the username that is there in the JSON Web Token and also the username in the user details, they match, and this token, it is not expired. So this will return true. Next we create the username password authentication token and add it in the security context holder. If we now move forward, we are again in the filter chain proxy. Next we'll go in the authorization filter. So now the authorization filter gets called. Now the authorization filter, since this request, it has already been authorized, so this decision, it will be true. So here granted is true. So if we now move forward, here we are able to hit the endpoint /employees. So this will just return us back the list of employees. So here in Postman, we are getting the correct response. Hope you have understood this tutorial. In the next tutorial, hope you have understood this tutorial. In the next tutorial, we'll be adding Swagger configuration for this Spring Boot 3 JWT example. Hope you have understood this tutorial. In the next tutorial, we'll be adding Swagger configuration to the Spring Boot 3 JSON Web Token example. Also, you can download the source code from here. Thank you.